Now we have some exercises involving strings and vectors, and the approach I want to take at this point, and actually probably for the first third of the course, is to just come up with any technique at all that works, that results in working code, and not worry so much about whether or not it's the fastest or most convenient technique. It turns out that, especially in C++, which has a huge standard library, there might be features of the language that we can use to come up with a faster or shorter solution. But because the standard library is so huge, I don't know whether it's worth it to go around memorizing standard library features. I don't think that's really that useful. On the other hand, if you were to spend a lot of time writing C++ in some domain-specific setting, of course you would become acquainted with the necessary parts of the standard library. And I guess that what this gets at is the idea that the only time it makes any sense to memorize parts of a language are when you use the language so often that you sort of memorize it by osmosis. Sitting down and staring at lists of standard library functions to memorize them isn't really that productive. And so, although there are a couple of bits of magic in the standard library that could help us, I want to focus, at least at first, on just any way of getting the code to work. In general, if you somehow need something out of the standard library in this course, so there's some specific standard library feature that's not obvious that you might need for an exam question or something, we usually give you some kind of reminder of that because we don't expect you to just pull that out of your head. And so one example is, I will need one bit of a standard library here, which is this function. And so you can see the prompt actually says, maybe you want to use this function. And so the task is, I have two strings, original string and lower string, and the goal is to, by the end of the program, have the variable lower string, which you can see starts out completely empty, to have that equal a lowercase copy of the original string, regardless of what it was that I set the original string to begin with. So I'll run the unmodified template just right off the bat to make sure we know what it's supposed to do. We can see there it is, and it prints out after we can see it's printing this empty string. So our goal, of course, is to fill that string up with characters. There is an implicit understanding that we shouldn't be modifying original string here. In general, when you're told to put the output in a specific place, maybe you make some new variables along the way, but you shouldn't be changing the other variables that were provided unless you're told that you can do so. So my preference when working with strings and vectors, with algorithms that need to take a vector or a string and produce some new vector or string, is to do anything I possibly can to make it possible to generate my output by doing a single left to right sweep over my input. It's not always possible, but I find that when it is, even if it requires a little bit more code, it's way easier to debug. And so the algorithm I'm going to use here takes advantage of this nice feature of C++ strings, which is that I'm allowed to add extra characters to the end whenever I want. So I've got my original string there, and then here's going to be my lowercase string. And the lowercase string starts out completely empty. So it starts out with 0 characters. What I'm going to do is I'm going to walk from left to right across my original string, and at each step I'm going to take one character, convert it to lowercase, and then stick it at the end of my lowercase string. I'm going to extend my lowercase string by one character at a time. So I do HELLO, then the space, then I convert W to lowercase, then ORLD. And so what I want to do then is I want to find some way of looping over my original string, so one character at a time, converting each character to lowercase, so converting the uppercase h to lowercase h, and then taking the resulting lowercase character and attaching it to the end of my lowercase string. Now, in the meantime, I'll have to figure out how I convert characters to lowercase. So it turns out that we've actually seen this library function before. It is a C library function. So it's an old friend coming to visit. We've already seen, and it turns out that the entire C standard library pretty much is actually part of the C++ standard library. You might recall in 111 when you wanted to use tolower, you would include ctype.h in C. In the C++ standard library, the C library headers are available by their usual name, but with the letter C in front of them. So for example, ctype.h becomes cctype in C++. Although you actually are allowed to just write tolower as the name of the function, I prefer to use the C++ naming convention of std::tolower, so I'm going to do that here. And just to remind you what the tolower function does, the tolower function takes a single character, and it's worth considering that in C, single character functions like tolower actually work with ints and not type char, although that's not going to be the end of the world for us. It takes a single character expressed as an int. So here we have, let's say, uppercase h. And the result, the return value of tolower, will be the lowercase version of that character. So uppercase h goes to lowercase h. Uppercase a goes to lowercase a. If I pass in something that is already lowercase, so lowercase b, it just stays as lowercase b. And then finally, if I pass in something that is not a letter at all, so there's a hash symbol, then it will just return that character unmodified. So in general, it only actually returns something different if what you pass in is an uppercase letter. If it's an uppercase letter, it returns the lowercase version of that letter. If it's anything else, it just returns the character you passed in, which is pretty much exactly what I want for this. I want to go through my string one character at a time, take each character, toss it into tolower, take whatever comes out, and stick that into my lowercase string. So that's what I'm going to do. Now to do that, I have to loop over every character in my original string. I've got a variety of ways of doing that, but we've already seen that one convenient thing we can do with strings in C++ is use this for each loop. I can say for each character C in my original string. Now you can also use a C-style indexing loop for this. You could just loop over every index of the string and use .at to go grab the character at that position. I generally think that unless you seem to need the index for something, there's no point in using an indexing loop, because the indexing loop has more machinery and that's more stuff that could go wrong. If you do need indices, then you can't use a for each loop. It's not going to help. But in this case, I don't care about the indices. I just care about getting each individual element. I don't care what position they occur at, because I'm just getting each element one element at a time. So what I want to do is I want to call tolower. I'm going to pass in the character that I've just taken out of my original string. And then all I have to do is attach that character to the end of my lowercase string. So I could do something like this: lower string plus equals. And we recall that plus equals extends the string by however many characters I've put over here. Now this is just one character. It's actually an int value being returned from tolower that gets converted to a character and then stored in this string. So what I'm doing at each step is taking one character, converting it to lowercase, and then attaching it to the end of my string, lower string. We can see there it is. And so I've got every character, but I've converted the uppercase characters to lowercase. When I work with strings, I like using the plus and plus equals operators and their variants as much as possible. But it's worth considering, because I'm only attaching one character here, I could also use pushback. So I could add one character to the end of my string using the pushback function. We'll try that out just to prove my point. So there it is. And it still works, and this is completely valid. You're welcome to use this. I should say, though, that when I write code with strings, I like not using pushback because it helps me remember that I'm working with a string and not a vector. You can't use plus equals on a vector, and you can use plus equals on a string. And therefore, if I always use plus equals when I'm working with strings, keeping in mind that we often use the plus operator on strings as well, it's easier for me to remember that I'm working with a string and not just a vector of anything. It's also true that if you work with other languages, which I often do, you will discover that almost every other language that has strings provides some form of plus operator or plus equals operator on strings, which is one reason why I use that as a default, because I'm so used to it from other languages. Of course, C doesn't have that, but also other languages don't have pushback. Pushback is a sort of unique C++ bit of terminology. Other languages have equivalent things for things like vectors or lists, but not specifically pushback usually. And so you'll find that typically when I write code involving strings, I tend to gravitate towards the plus and plus equals operators even when pushback is available. And it's worth also considering that the compiler doesn't really care. The compiler probably turns this plus equals operation into a call to pushback if pushback truly is any better for this application. So it's one more reason just to stick with whatever code makes sense or is readable to the author and to the other people reading the code.